Namaste, Abhivadam to the viewers of Swayam Prabha. MalladiAcademy.com offers you greetings for Vijayadashami, the state of self-victory through subject mastery. This column was done by my daughter-in-law Pratyusha in Bangalore on this occasion. Introducing essential engineering mechanics with simplified integrated methods of solution, aim with SIMS. I am Narasimha Siddhanti Malladi. Got my mechanical engineering degree from Osmania, machine design M.Tech from IIT Madras, and PhD in mechanisms from Oklahoma State University. I worked for IIT Madras, Tuskegee University, Yale University, JNTU Kakinada, Control Data Corporation designing automatic disk drives and ATM mechanisms at Diebold, railway actuators for Templeton Kelly and Company, and finally shuttle mechanisms and linkages for Kennedy Space Center in Florida. I am now with Malladi Academy, Edinburgh, Texas State, USA, home of University of Texas, Rio Grande Valley. No matter how much theory we study in a subject, especially in engineering, ultimately it boils down to solving problems. So let us take one such problem in engineering mechanics, which is the study of forces. So a mother and her daughter are carrying a 10 kg bag. Find the force in each of their forearms. So here is the picture drawn by my cousin brother's eldest daughter-in-law. I requested her to draw this one for this problem, and she did it. Okay. Here we are. Her forearm is experiencing a force because she is pulling in this direction, and her forearm, the daughter's forearm, is pulling in this direction, and this is a bag in equilibrium. That means not moving. Okay. So it's not rotating either. Therefore, we can idealize this as a particle, and this is, let us say, 120 degrees approximately from the horizontal. See, like this. Okay, that is, it is 30 degrees from the vertical, like that. Okay, so this is at 30 degrees from the horizontal here. So, and this is a 10 kg mass, and as a force it will be called 10 kgf. Usually it should be converted into newtons, but we are using a MathCAD program, so this will automatically convert this kgf into newtons, as you can see very soon. T3, there are 10 types of problems in engineering mechanics that I have written in this book, and so we'll discuss more about it. Okay. Now, since the body is in equilibrium, all the vectors, that means a vector is one which has a magnitude like A, B, or 10, and a direction like 30, 120, and 270 here. I did not put 270 mainly because what is obvious need not be shown right here, but it can be shown in an equation here. So vector A has a magnitude of A, and it is theta A is 120 here. This is known as the unit vector, and the vector symbol is shown here. Okay, and B, and this is equal to 0. We can call this as a vector equilibrium equation. Now, I can rearrange this equation so that it looks like a simultaneous equation in the sense in which all the unknowns are on the left and the known constants are on the right. So this becomes a simultaneous vector equation, and so I can generalize it as vector A plus vector B is equal to vector C. So we can call it becomes a vector simultaneous equation. Okay. Now I made it scalar. This equation has two components. One, a horizontal component consisting of sine here, and a vertical component, each vector, sine. So in equilibrium, in plane, all the forces should be equal to 0, or in the sense, that we did it already here, so we don't have to do this. So this is uh, a vector, a vertical equation, and this is the most useful for here. You will see why. So I apply symmetry sine equation with subtracted line angle theta b. I can use theta a or theta b. I choose theta b. So I subtracted this. So when I subtract the angle, it is amounting to rotating the whole set of the three forces by 30 degrees clockwise. So B becomes horizontal, or vector A, and A becomes vertical, and this becomes, turns uh, to angle 240. Okay. Now 270 minus 30. So the idea here is to, when you take a vertical component, so B will have zero vertical component. That's what we are accomplishing here. So we are making sine theta equal, therefore B is eliminated. Okay. So therefore, in this equation, only A is unknown. So you can easily find out A by transposing this multiplier here. In the same way, if I subtract A, so A will be theta A will be eliminated, and you can find out B. So that, therefore we are converting simultaneous equations in two or more unknowns, or usually two in this case, and single unknown equations obtained, which is very easy to solve. All this is theory. Okay, this is done in a MathCAD environment. So all this is in the comment section, and this picture was drawn elsewhere and then put here, etc. Uh, Now, data. The data should reflect what is known as well as what is unknown. So A is unknown here, and this is the symbol for the equation, and you will see, and this is the equation for, sign for actual calculation. So this is it. The angle should be very clearly mentioned in radians. If you don't put the degree sign here, it assumes to be radians, which is not desirable for us here. Okay, and all. So this equation is A is equal to, okay, see, A is, we can say, this equal to 86 calculation. This is answer 1, and B is like this. So the advantage of doing MathCAD is you put the data, and there are two unknowns. So I have a direct equations for the two unknowns, sim3, and I applied sim3 again. All right. So in 3 steps we got the answer, and you can generate any number of problems. Once I was a technical teacher trainee in 1960s at IIT Madras. There was a chemical engineering professor who used to say that the best way to teach a subject is to teach 100 symbolic problems, and ask the students to practice them by changing the data. And in the final examination, he would give 100 similar questions which change data. And if there are 20 students, each will pick up by lottery 5 problems from there. And so everybody would have mastered those problems, and everybody has a chance to get an A without any surprises. So in a way, I am following the same principle here, and we'll discuss that later again. Now, I am following a Panchatantra principle, okay, five-fold plan for subject mastery. And at home, I provided reading material, okay, for each class, and also review pages. Then you will have a chance to watch a review video just like this. And number 3, do interactive prep tutorial, interactive with MathCAD program. Okay. Then the 4th step is to, in the class, discuss, watch the problem based video. Okay. It could be live, or it could be a video too by your professor. After class, 5. Complete the interactive class tutorial. So this will give a several chances to master the subject. How did I come about this particular procedure? In 1953, when I was a failing student at a high school, my mother, who studied only up to 5th grade, said, "Son, just as I soak the mung beans in the night before grinding them to make pesarattus, that is dosa, pancake, you soak and prepare your mind by 1. Reading the textbook, number 2. Reviewing it yourself, number 3. Answering questions and answers, answering the questions at the end of each chapter. Then 4, attend the class and participate in it actively. And then finally, complete the homework immediately after the in the end of the school. Then you will have sure success. I religiously followed it, and I call this as Pesseretto Principle for Sure Success, PPSS. And I won the gold medal at my high school, and all my education was due to scholarships thereafter in my BE, in my MTech, and as well as my PhD in United States. So, now let us elaborate slightly these 5 steps. At home, read the class and review pages. And you can order my paperback, okay, book. And out of patriotism, I prefer to publish it by uh, a Norton Press situated in Chennai. I visited them several times. And then, and this is also available freely from me and on the internet also. Okay. And my manuscript looks like this, slightly different here. So this is the same Godavari Bridge in East Godavari district, and this train is approaching the Rajamahendravaram, where I was born in 1942, August 1. And this is the dedication page to the Divine Mothers and also the mothers who fed me while I was in high school. Since my mother lived in a different village, so I used to eat one day of a week in a house. They were all nice to me. And this is a typical page of the contents, and the course has 60 classes with 10 classes in each unit. And this is the problem that inspired. This is the problem by Timoshenko and Young textbook of engineering mechanics. And you all know that Timoshenko is the modern father of engineering mechanics. So there is a problem that looks like this with 2 balls rolling in a bowl, and it is done in a roundabout way. Solution is available, but I simplified it. In fact, this is the problem that was given in an examination that inspired me to write this book. Okay, and eventually discover all the files are not new, but they are put in a systematic way. So all materials will be available at malladiacademy.com. Okay. Now, how is this book, Engineering Mechanics, different from the traditional books? I listed 16 reasons and or differences, slight differences, you can say, and and I consulted about 15 standard textbooks, both from India as well as United States authors, and most of the books I taught them over my career, both in India at IIT Madras as well as other. Now, number 1, this is the traditional method, and this is the E with Sims by Malladi. That's me. Now, 1, laws of science for a triangle. I derived it. I derived the laws of science, and using easier symmetry, errors are avoided this way. And Lami's theorem, which is also another form of law of science, and we use symmetry, and the advantage of symmetry is not limited to 3 forces like it is in Lami's theorem. And many students make a lot of mistakes if they don't take the direction properly. They end up with negative magnitudes, etc. That's not so with symmetry. Now, Cartesian coordinates, okay, I and j, etc. And I use easier polar coordinates with a new notation. And you end up with lots of simultaneous equations if the forces are more than 3, but here we use only single unknown equations. thanks to Sim 3. Now, there are more steps and more calculations, less steps and less calculations. Complex notation, simplified notation, unified notation, handwritten and calculator use. Here you can use OpenOffice to draw the figures once and for all and modify them, and use MathCAD to solve several problems at one time. And moments by XY and inspection. In simple polar method, there are no inspections necessary. When once you put the polar angle, it will take care of the sine or cos or whatever. I mean, it takes the signs properly. X components are always cos components, and Y components are always sine components. It removes the confusion about sines and choosing between cos and sine. Several formulae, only 5 sims, okay, and hundreds of 2D problems. Some books claim that you have solved 600 problems, etc. Here, you use only simplified notation and only 10 types of problems are solved, and by changing the data, you can hundreds of problems. Now, complicated 3D methods, IJK. I have simplified even the notation and the methods also. Length centroid and MI, at the moment of inertia. Again, I made the formulas simpler. Simple is the hallmark of this book. D'Alembert's principle. Processes are equated to zero even in a dynamic system. Again, they have to be arranged. Therefore, I use FBD is equal to effective body diagram, and that makes calculations very easy and lesser steps. Virtual work problems. Virtual work is an introduction to finite element method, etc., but that need not be addressed in engineering mechanics. It can be taught when it becomes relevant. So instead, I use a simpler canonical moments problem, because the units of moment is same as the unit of work. Okay. Several FBDs are usually done for a truss, whereas by simply knowing the truss member angles, a single FBD truss analysis can be done very easily, and it is demonstrated here. Number 16, non-interactive tutorials are in the traditional books, whereas this book is interactive mathematical tutorials, prep tutorials as well as class tutorials. Okay. Now, watch the author's class review video. So the videos will be like this, and here I explained, what is how engineering mechanics develops visual and as well as analytical skills, etc. And here again, problem. These are the slides, some of the slides, and do the prep tutorial. Let us see how a typical prep tutorial looks like. Okay, it consists of uh, problems with 4 problems, and here I am determining angle and like this at different axes, and how do you do it systematically. And if you get it the right answer, you get 2 points here in these questions, and if you do it wrong, and you have a chance to correct it, and then give yourself only 1 mark. Like this, there are 4 questions. Okay. And then finally we solved a similar problem that we already solved, and it's given 12 and the marks in stages. And so if you get 20, or if you make 90 out of it, you get an A basically. So this is explained further later. Now let's come back to this. Okay, and there is a class tutorial as well as also for this. Now during the class, listen to the professor and discuss, and after the class, complete the class tutorial. And after every 10th class will be a unit test that will have 2 class tutorials, and this will help you to master the subject and again correct mistakes. Ultimately, let me talk about all yes by all. So we have seen the final examination set will have 6 questions and problem sets. Okay, one from each unit, similar to the class tutorial. So that means if you get a step right, you get full marks. If you get this step wrong, you get half marks. So this way, if you get 80% of the marks right, then you get 10% of the for correction. So totally it becomes 90%. So if you do the secure 90% score in the first sitting, you get 10 by 10. If you get the second sitting, you will get 9 by 10. Third sitting, you get A3, 8 by 10, and fourth onwards, A4. So therefore, this corresponds to 70% in the first sitting of United States, and I think this is a universal way of grading, and everybody can get an A. It's a matter of practice. Thank you very much for your listening. We will discuss more about this as we get into other classes. So next time we will be discussing class 1. This is supposed to be class 0. Thank you and namaste and abhivadam to everybody.